Okay, so this video is going to be titled Polyatomic Ions. Alright, so hopefully by now you guys have memorized the polyatomic ion sheet. You can find it, let's see if I have it, it's right over here. Hopefully you guys have this down. Very, very important for naming metals that contain polyatomic ions and of course acids. So hopefully you guys have that down pat. So assuming that you guys know that entire sheet, and if you don't, please study it. We're going to move forward. So a polyatomic ion, okay, is just an ion containing more than one atom. If you remember before we had polyatomic ions, we had regular ions. We had sodium plus, we had Cl minus, oxygen 2 minus, fluorine minus, Ca2 plus. These are just regular ions containing only one atom, okay? But the difference with these ions, what makes it an ion is the charge specifically. The charge is what makes it an ion, whether it's positive or negative. Remember, metals tend to have a positive charge because they're cations. Chlorine, or chloride in this case, has a negative charge because it is a nonmetal. You should also know that when these become ions, in this case an anion, we lose the IDE ending, the INE ending, and we make it an IDE. So chlorine, for example, the element chlorine, when it becomes an ion, it becomes chloride, which is Cl minus. Same thing with fluorine, okay? Fluorine, if it doesn't end with INE, we just leave it as is. We just say, for example, sodium, right? Sodium doesn't end in INE, so we just say sodium ion. Or if we had oxygen, oxygen does not end in INE, so it's just oxygen ion. Or if you want to be more specific, oxygen anion and sodium cation. Fluorine ends in INE. We're going to make it a fluoride anion. Calcium, 2 plus, we're going to make it a calcium ion. More specifically, a calcium cation, right? Because it has a positive charge. It's losing 2 electrons, so it's going to have a +2 charge. All right, then we started moving on to polyatomic ions, okay? Poly, like polytheism, means more than one. So we're going to have more than one atom with charges associated with it. So for example, we have chlorate, sulfate, cyanide. All of these guys have a charge associated with them. Okay, whether it's minus, 2 minus, goes on. Okay, the list goes on. So the key distinction here is the charge. The charge, again, is what makes it a polyatomic ion. It has a very, very straightforward name. Chlorate. Chlorate, that's what we memorized, okay? If there was no minus charge here, if it was just ClO3, what would we name this? We would just name this chlorine trioxide. What about the sulfur? Sulfur SO4 2 minus, okay? So normally this is sulfate. If we take away the 2 minus charge, it becomes sulfur tetraoxide. What about the Cn minus? So with the minus, it becomes cyanide. It is a polyatomic ion known as cyanide. Without it, it's just carbon mononitride. Notice how, again, carbon mononitride ends with NIDE. Okay? So an ion, again, is an element that has, it ends with either ion or ide. We had a sodium ion. We had an oxygen ion, but it also ends, if it has an INE, we replace it with IDE. So chlorine becomes chloride, bromine, bromide, etc. You guys get the idea. So a key distinction here for this video is note that the negative charge or the positive charge, for example, ammonia, if I'm talking about ammonium, NH4+, this is ammonium. Without this plus sign, it's just nitrogen tetrahydride.